All right, we're on 9.5, and we're going to be solving linear inequalities. There's two things really we're going to be doing, and the other thing that we're going to be doing is we're going to be solving quadratic inequalities. Okay, so what's an inequality, folks? Well, remember, an inequality, there are really 5 different inequalities. We're going to focus on 4 of the 5 inequalities that we have. We have the inequality that looks like that, which is less than or equal to. We have the inequality that looks just like this one, but turned around the other way, which would be greater than or equal to. Then we have the inequality that's like the first one, but it doesn't have the line underneath it, so it's just the less than symbol. And that's exactly what it stands for, less than. And then we have the greater than inequality symbol, which is the less than symbol, but turned around the other way. No line underneath it, and that would be greater than symbol for an inequality, okay? So we're going to be solving these inequalities. And if you notice, example number 1 for the linear inequalities has a greater than symbol. Example number 2 in the linear inequalities has a greater than or equal to symbol in it. All right, so how do we solve these? Let's go about solving these. So in example number 1, and by the way, when you solve these equations, you solve them exactly like you would as if instead of an inequality symbol, a greater than symbol, you would solve them exactly as if there was an equal sign in the equation. So there's really no difference between solving the equations if it has an equal sign or one of these 4 inequality symbols, okay? There's one particular instance where you have to worry about doing something special, but we don't really cover those. So in example number 1, to solve this equation, my first step would be to divide both of the sides of the equation with 6. That would cancel out the 6's on the left, and then that would create the equation -7 plus x is greater than -10. All right, my next step would be to add 7 to both sides of the equation. And we're going to add 7, excuse me, to both sides of the equation. That would cancel out the 7's, and that would leave me with actually my solution, which would be x is greater than -10 plus 7 is -3. All right, and so that right there, that is my solution to the equation. Now, after we find the solution, we are now going to graph my solution on a number line. And sometimes in the number line, you already have the numbers on the numbered line. As you can see, when I look at worksheet 9.5, you can see you have the numbers on the number line sometimes. Sometimes the number line is blank and you're expected to fill out the number line itself, okay? So, and if there's no numbers on it, here's what you do. You're going to go right to the middle and you're going to put that solution number in the middle. That would be -3. And then you're going to make some tally marks or tick marks to the right. You're going to make some tick marks to the left, and you're going to fill in the numbers on the number line. To the right would be the next numbers larger than that solution number -3, which would be -2, -1, 0, and +1. To the left, you would fill in the numbers that are smaller than -3, -4, -5, -6, and -7, okay? Now, to graph my solution on the number line, I'm going to put a dot at my solution number. My solution number is this number right here, -3. Okay, so I'm going to put a dot on my number line at -3. But here's the catch. Sometimes you put in a filled in dot. Sometimes you put in a open, not filled in dot. And as you can see, as I'm writing it as I speak, I am showing you which inequality gives you which dot you put in on your number line. So the less than or equal to and the greater than or equal to inequalities, you put a filled in dot on your solution number on your number line, at your solution number on your number line. For the less than symbol or the greater than symbol, you put in not filled in dot at your solution number on your number line. So for this particular equation here, I am going to put a not filled in dot at -3. And then I'm going to draw an arrow from that dot either to the right or to the left, okay? And what I do is to tell which way I draw my arrow, so I'm going to draw an arrow from that dot either going that way to the right, like I just drew it, or I'm going to draw it the other direction to the left, which is like going that way right there, okay? So how do you tell which way you're supposed to draw your arrow? Here's what you do. You check a point, all right? So what you do is you take any point on your number line other than your solution number. So you could take -2, -1, 0, 1, or -4, or -5, or -6, or -7. It does not matter, and you are going to check a point, okay? And the point that I'm going to choose to check is 0. So I'm going to choose to check when x is equal to 0. So what does that mean? It means I'm going to take my equation, 6 parentheses, -7 plus x is greater than -60, and I'm going to substitute 0 in the place of x. That would make my equation 6 times -7 plus 0 is greater than -60. And I'm going to work this equation out, and I'm going to determine, would the equation after I work it out, would it be a true equation or would it be a false equation? So working this out, -7 plus 0 is -7. -7 times +6 is -42. So I get a -42 is greater than -60, right? Well, that right there, that result that I just got, that is a true result, okay? This is a true result. -42 is greater than -60, all right? And so what that tells me is that when I draw my arrow from my point on my number line, I draw my arrow going towards the number that I picked, which is 0. So I'm going to draw my arrow going towards the 0 in that direction. And the reason why I did is because that tells me that all the numbers to the right of -3 are a true solution to this problem. It's all the numbers greater than -3, okay? If when I put in the x equals 0 and I got a false result, then I would draw my arrow from my point going away from the 0, which is the number that was my point that I checked, okay? So there's the idea, you guys, on how we solve a linear inequality. Okay, let's do example number 2. Once again, you solve the linear inequality exactly as if there were an equal sign instead of the greater than or equal to sign, or whatever the inequality symbol has to be. So how would I solve this equation right here? Well, my first step would be to minus 6 from both sides of the equation. That would make my equation 6 times the quantity 4 minus 2x. The 6's would cancel each other out, right there and right there. And then it would be greater than or equal to 138. My next step now is I would divide both sides of the equation with 6. All right, and that after I divide by 6, that would cancel out the 6's. That's good. And now that would make my equation, and I'm going to write my equation over to the right. 4 minus 2x is greater than or equal to 23. And then I would continue to solve this equation. My next step would be to minus 4 from both sides of the equation. That would cancel out the 4's. And then that would make my equation negative 2x is greater than or equal to 19. And then my next step would be to divide both sides of the equation with negative 2. Okay, now, I don't know if you remember, but a while ago, about 11 minutes ago, I had said that you solve these equations exactly the way you would if there was an equal sign, but sometimes there's a special little twist. Here's the special little twist. If you ever divide by a negative value, we call this the dividing by a negative value rule. You have to flip the inequality symbol around. You have to flip it around. So it has to go from greater than or equal to less than or equal to. Okay? And then it would be negative 9.5. 19 divided by negative 2 is negative 9.5. Okay? It's kind of it's a weird sort of rule, but then that's what you do. Okay? So you're going to flip the inequality symbol when you divide by a negative value. Okay? Now, that negative 9.5, that is my solution number. So I'm going to go to my number line right in the middle. I'm going to put a negative 9.5. And then I'm going to put a couple tick marks or tally marks to the left and also to the right. I put 3 each way. Earlier I put 4 each way. Either way, it doesn't matter. And then to the right of negative 9.5, I'm going to number off the whole numbers that are immediately larger. Negative 9, negative 8, negative 7. And then to the left, I'm going to put negative 10, negative 11, and negative 12. Okay, so now I'm going to go to negative 9.5. And I'm going to put a dot at my solution number on my number line. And since my inequality is a less than or equal to inequality, I'm looking at this solution right here. That means at negative 9.5, the dot that I put is a filled in dot. Okay, and then I'm going to check a point to see which way I'm going to draw an arrow on my graph. Okay. So I'm going to check a point. And which point you decide to check is entirely up to you. I'm going to check when x is equal to, let's do negative 10. Okay, so I'm going to check a point to the left of my dot this time, negative 10. All right, so what does that mean? Well, it means that I take my equation, which was 6, then parentheses 4, minus 2, but instead of x, I'm going to substitute the negative 10. So I'm going to have this double parentheses right there. Plus 6 is greater than or equal to 144. Okay, notice that when I plugged in the number that I'm checking, I plug it in into my original equation. So I'm going back to the greater than or equal to symbol. And then I work this out. Okay, so -2 times -10 is 20 positive. So I would get, so this, when I work this out, I get 150 is greater than or equal to 144. All right, and that is a true result right there. So that means when I worked out everything on the left, I just typed it into my calculator exactly as I wrote it. I got 150, and then it's greater than or equal to 144. That right there is a true result, right? So what does that tell me? Well, it tells me when I go back to my graph, I checked -10, and it was a true result. So that means my arrow on my number line is going to go to the left towards the -10, which tells me my solution is all the numbers less than or equal to -9.5. Okay, so that's going to be how we do solving the linear inequalities. Now let's go to solving the quadratic inequalities. Okay, so in the quadratic inequalities, it's going to be the same idea, more or less, but the difference is instead of a linear equation, I'm going to have a quadratic equation. Okay, so how about we go with x squared minus 6x minus 7 is less than 0. All right, and what you'll notice in these, when we're doing the quadratic inequalities, we're always going to have the right portion of the inequality as a 0, okay? So here's what I do. And once again, I solve this exactly as if there were an equal sign instead of the inequality symbol, okay? So how am I going to solve this equation? Well, I could solve it by the quadratic formula, or I could solve it by graphing, or by factoring, excuse me. So I'm going to go ahead and factor this equation, and I'm going to solve it by using my factors. Okay, so I set up my area model, my diamond problem. X squared, top left, minus 6x, bottom diamond, minus 7, bottom right area model, which means the top of my diamond is minus or negative 7x squared. I solve my diamond problem with a negative 7x and a 1x. I move the 1x and the negative 7x into my area model. And then the outside parts of my area model are my factors, which would be x plus 1 and x minus 7. And now I'm going to use those factors, x plus 1, and I'm going to use the other factor, x minus 7, to solve my inequality. Okay? And this is going to give me two answers. So how do I solve my inequality? What I do is I take both of my factors, x plus 1, and I write an equation using that factor less than 0. Okay? And then I take my other factor, x minus 7, and I write an equation less than 0. And I solve both of these equations, and this is going to give me an answer of, so when I minus 1 from both sides of the equation to solve the x plus 1 is less than 0, I get x is less than negative 1. Okay? Then when I solve the x minus 7 is less than 0 equation, I add 7 to both sides of the equation. That gives me x is less than 7. So what this tells me is that I have two solution numbers, negative 1 and positive 7. Okay? So when I go to my number line and I make my number line, I'm going to have a solution number at negative 1, and I'm also going to have a solution number at positive 7. Okay, so I'm going to have two solution numbers, and on both solution numbers, I'm going to have an open dot or a not filled in circle, not filled in dot on each numbers. Why a not filled in? Well, because my inequality is a less than symbol, and you can see up here when we have the less than symbol, we put a not filled in dot. But we have two dots here. All right, now what I have to do is I have to check a point. Okay, so I'm going to check a point. Now, here is the point that you're going to check. You are always going, the point that you're going to check will always be a number that's in between your two dots. So pick any number between -1 and +7. 0. Or 1, or 2, or 3, or 4, or 5, or 6. You can pick any one of those numbers. I'm going to pick 0. It's usually the easiest number to pick. And I'm going to then put that 0 into my equation. So instead of x squared, I'm going to have 0 squared minus 6. Instead of x, I'm going to have times 0. -7 is less than 0. Okay, and I'm going to work this out. When I work it out, I get -7 is less than 0. Now, this is a true result. Okay, so what does that tell me? So it tells me that I'm going to, you know how in the previous problems we drew an arrow? Well, in this problem, since 0 was a true result, it means that I'm going to connect the two dots together. Not with arrows, but I'm going to connect the two dots. So what does that tell me? It tells me that any number along that line between -1 and +7 is a result to my quadratic inequality. Okay, now what would happen? I'm just going to show you this. This is not the case for this problem. What would happen when I checked the point if it turned out to be a false result? So if it was a false result, then what I would do is I would draw arrows from both of my solution points going away from each other. Okay, so that's what we do when it's a false result. But I got a true result, so I connect the arrows. Okay, now we only connect them, and the reason is because we tested a point 0, this case, in between the two values there. All right, let's go to example number 2. Do another one where we do a quadratic equation. Okay, so here's my quadratic inequality. Sorry, I said equation, I meant inequality. It is x squared minus 6x minus 27 is greater than or equal to 0. Okay, so I'm going to solve this equation just as if there was an equal sign instead of the inequality greater than or equal to. And I could solve it using the quadratic formula, or I could do the factoring. This one could be factored, so let's go ahead and use the factoring. Factoring seems to be the preferred method. A little bit easier, maybe. Okay, so to factor it, there's my area model. I'm going to put the x squared in the top left. I'm going to put the -27 in the bottom right. I'm going to draw my diamond problem. I'm going to put the -6x at the bottom of the diamond and the -27x squared at the top of my diamond. I'm going to solve my diamond, which would be -9x and +3x. I move the 3x and the -9x into my area model, and then the outsides of my area model are my factors, which would be x plus 3 along the top and x minus 9 along the side. I write my factors down, parentheses, x plus 3, close the parentheses, new parentheses, x minus 9, close the parentheses, is greater than or equal to 0. Okay, and then once again, I take both of my factors, x plus 3, and I create an equation. X plus 3 is greater than or equal to 0. And then I use my other factor, which is x minus 9 is greater than or equal to 0. And I solve both of these inequalities. Solving x plus 3 is greater than or equal to 0. I minus 3 from both sides of the equation. That gives me x is greater than or equal to negative 3. Do not flip the inequality symbol. You only flip it when you divide by a negative number. You don't flip it when you subtract. Okay, solving x minus 9 is greater than or equal to 0. I would add 9 to both sides of the equation. That gives me a solution of x is greater than or equal to 9. We good so far? Awesome. So there's my two solution numbers, negative 3 and positive 9. I go to my number line. I'm going to put negative 3 on my number line. I'm going to put positive 9 on my number line. Leave a decent amount of space because there's a few numbers in between those two. You don't have to fill them all in. And now I'm going to put a dot on each one of those numbers. Now my inequality symbol, which is greater than or equal to, dictates what kind of dot. Notice up here, greater than or equal to means we put a filled in dot, closed dot, however you want to say it, on both of the negative 3 and the positive 9. And now I have to check a point, okay? And the point is going to tell me, should I connect the two dots on my graph or should I draw arrows going away from the two dots? Okay, so I'm going to check a point. So which point do I want to check? And remember, when you check a point, you're going to pick any number that's in between your two solutions, negative 3 and 9, any number. Now, once again, I have a lot of choices, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. I could pick any of those numbers. I bet you know which number I'm going to pick. I'm going to pick 0. 0 often is the easiest number. I'm going to take that number 0. I'm going to plug it into my original inequality. So I'm going to get 0 to the second power minus 6 times 0 minus 27 is greater than or equal to 0. And I'm going to work out the left side, which when you work it out, you type it into your calculator. That would give me negative 27 is greater than or equal to 0. Now, that is a false result. Negative 27 is not greater than or equal to 0. False result. So what does that mean? It means when I go to my graph, I will not connect my 2 points. I will draw arrows from the 2 points going away from each other. Okay, so what does that mean? Well, it means that my solution to my equation is any number smaller than negative 3, including negative 3, or any number 9 or bigger. So if you picked a number 9 or bigger, or negative 3 or smaller, and put it into your inequality equation, it would give you a true result. Okay, so there we go, you guys. There is 29 minutes of solving quadratic inequalities and solving linear inequalities, which is 9.5.